Assignment 2, Part 7. The first thing we need today is the Pythagorean theorem. Most students know this already, and that's just a squared plus b squared equals c squared. And the key is this is your hypotenuse. Sorry, had to squeeze it in there. So this is your hypotenuse. So when we talk about these problems, short leg, long leg could be either A or B. It doesn't matter. Okay? So I like for these problems, instead of using A squared plus B squared equals C squared, I like using, because these are all the same, S for short leg, L for long leg, H for hypotenuse. So I go with these problems S squared plus L squared. The order there doesn't matter, equals H squared. All right. One thing that will help you out, one thing to focus on is that whenever you see is, that's when you're thinking equals. Is like equals. Okay, so the hypotenuse of a right triangle is 10 meters long. So we know H equals 10. So there's already one of our answers. The longer leg is, so I like writing L equals, longer leg is 2 meters longer than the shorter leg. I always put this after. It doesn't matter for addition, but if there's ever subtraction, you kind of have to read it backwards. So if it's 2 meters longer than the short leg, the way I like writing it is S plus 2. Find the side lengths of all the triangles, and then we still have S. So we're going to write this problem as our S is just S because they didn't tell us that, plus our L is S plus 2 squared, and our H is 10 squared, which is 100. You can jump to the 100 if you want. Okay, this will end up being a factorable quadratic. All right, so S squared, we have to FOIL S plus 2 squared. Don't square both pieces. That's illegal math. So we have to FOIL this. So we get S squared plus 4S plus 4. Because S times S is S squared. S times 2 is 2S. 2 times S is 2S. That's where the 4S comes from. And 2 times 2 is 4. Equals 100. All right, so we're going to end up with 2S squared plus 4S. And then you subtract 100 from both sides, minus 96 equals 0. Okay, to make this factor much easier, there's a GCF here. 2 goes into everything, so take out your 2, and it'll make factoring much easier. And 96 divided by 2 is 48. Okay. So when we factor, we can kind of ignore this 2. This 2 equals 0 doesn't mean anything to us. So we're going to break down the quadratic, and these will all work out. So S and S, what multiplies out to negative 48 that adds up to 2? Well, that's, some of you might have to write out the factors of negative 48. Some of you can just figure it out. Some of you might need to, use a calculator to help you. So we get plus 8 minus 6. 8 minus 6 is 2. 8 times negative 6 is negative 48. So we set both pieces equal to 0. We get S equals negative 8 and S equals 6. But because we're dealing with triangles, your side, your S, can't be a negative number. So we're always going to exclude the negative answer, at least for these problems. I mean, there are probably scenarios where if there was other stuff here, it could possibly happen. But when we have S, there's no way it can be negative. A side of a triangle can't be negative. You can't measure something and have a negative side. Okay? So S equals 6. And then we're going to plug it in here. 6 plus 2 is 8. So we have 10, 8, and 6, and you would put it into the appropriate place in Alex. Okay, the key here is this is an ugly quadratic. By taking out the GCF2, you're left with something much nicer. Okay. Here's one more problem to try. So if you want to set up your three equations, pause it. I'm going to write them out. Okay, here we go. So the first one, the length of the longer leg of a right triangle is. So the longer leg is 3 feet more than 3 times the length of the shorter leg. So 3s plus 3. Could you write 3 plus 3s? Sure. But if it's ever less, you have to write it in this order. If you ever have a minus, the minus will always go after the letter. Okay. The length of the hypotenuse is 4 more than 3 times the length of the shorter leg. So 3 times the shorter leg and then 4 more. Find the side length of the triangle. And of course, we still have our S. Okay, so this one looks a little more complicated. So we're going to set up S squared plus 3S plus 3 squared equals 3S plus 4 squared. Okay, so we have to FOIL both of those, just like we did on the last problem. 3s plus 3 times 3s plus 3 is 9s squared plus 18s plus 9. Okay, because 3s times 3 is 9s, and then 3s times 3 is 9s, which gives you the 18s. And here we're going to get 9s squared, 3s times 3s. 3s times 4 is 12s, and then we have two of them, so 24s. And 4 times 4 is 16. All right, I'm going to move everything over to this side. So if I subtract, you don't have to show this workout. You can do this in your head if you want. Just be careful. It depends on how comfortable you are. Okay, so that's nice. That cancels. It's a nice Alex problem, so it's going to work out really nice. So I know I'm going to bring down the s squared. I'm going to subtract 24s from both sides. Sorry about that. Minus 6s. And I'm going to subtract 16 from both sides. Minus 7 equals 0. Okay, it looks like this one will factor. So this factors into an s minus 7 s plus 1. Because negative 7 times 1, negative 7, negative 7 plus 1, negative 6. Now here we get s equals, if we set this equal to 0 and add 7, we get s equals 7. Here we get negative 1. We don't want that one because the side can't be negative. So we get s equals 7. And then we're going to go back up here. So if s is 7, h is 3 times 7, which is 21, plus 4 is 25. And L, 3 times 7 is 21, plus 3 is 24. Okay. And just a little hint for this to work, your biggest number should be the hypotenuse. I know these are close, but this is still bigger. So shorter, longer, and this hypotenuse will always be the longest. So this makes sense to me. Even on the last problem, I didn't mention it on the last problem, but short 6, long 8, hypotenuse 10. Hypotenuse will always be your biggest. Okay? Okay, next. Solving a quadratic equation with complex roots. I wrote myself a little note in here. Use the quadratic formula. Simplify your answers to a plus bi. So they do want your answers simplified. So first thing, quadratic formula. It's the opposite of b plus or minus b squared minus 4. I usually put this in parentheses just to be safe. AC all over 2a. Okay. And that's given ax squared plus bx plus c equals 0. So you'll never put any letters into here. So negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So we have our a here, we have our b here, and we have our c here. And if we try AC method, this won't factor nice because we get complex roots. You're going to always have to use this. There are some other methods out there, but this is the one they're using. This is probably the easiest. So the opposite of 6, so minus positive 6 is just a negative 6, plus or minus 6 squared minus 4 times A times C all over 2 times A. Now, the only reason why I put this in parentheses is if this is negative, and in your calculator, if you do negative 6 squared, the calculator is going to lie to you. Okay, so this is positive, I know, but in a calculator, if you're trying to square negative 6, which isn't the case here, you would need to type this. If you type this, it would give you a wrong answer. So that's not the way we want to do it. So over here, it really doesn't matter, but if there's a negative, you have to be careful. All right, so we get negative 6 here, plus or minus the square root. Okay, we get 36 for AC. Okay, we get 36 minus 12, which is 24. All over 6. All right, so usually with complex roots, usually we have a negative here. Okay, just continue off. I caught myself a little mistake. So this is 36 minus 12. Oh, no, we're good. Never mind. We're okay. So this is 24. Typically in this section, we get an I here. I don't think you'll get a positive number. So I'm just going to show you how to break this down. Then we'll look at a problem with I, because typically this is negative for this section. I just picked a bad problem. Okay, so what we're going to do here is, even when we get an I here, which we'll see next, we have to break these down. Okay, and then 24, what's the biggest perfect square that goes into 24? Okay. So the biggest perfect square that goes into 24 is 4. So that's going to break down to radical 4 times radical 6. So we would rewrite this as, I'll simplify after, radical 4 is 2. So we get 2 radical 6 over 6. So we're going to simplify. The negative 6 over 6 is negative 1. And 2 over 6 simplifies to 1 over 3. So we get square root of 6 over 3. Now, typically when we do these problems in this section, you'll see in the next problem, we have an I here. And that's why they want the answer as an A plus BI. I just gave you a bad example. But there's good pieces. Quadratic formula, nothing changes. Simplifying, nothing changes. Just this will have an I. Okay, so let's look at the next problem and we'll see that. Okay, there we go. So negative b, so negative negative 1 is 1, plus or minus the square root of negative 1 squared minus 4 times a, which is 8, times 2, which is c, all over 2 times 8, which is 16. So we're going to get 1 plus or minus square root. Here we get 1 minus, we get 16, 32 times 2, 64. So negative 63 over 16. Just like I promised, we're going to have a negative there. So first step, and you can combine some of these steps, always take out that negative. That negative becomes an I in the front. I like putting in the front. We'll rewrite it after. Go over 16, over 16. Now 63, the biggest perfect square that goes into 63 is 9. Okay, so that's 3 square root 7. So we get 1 over 16 plus or minus 3 square root 7 over 16. And they like putting the I after. I like putting it before when I take it out, but the final answer has to be that A plus BI. And the 3 and the 16, nothing goes into 3 and 16. The only thing that goes into 3 is 1 and 3. 3 does not go into 16. So that is the final answer. So you have to check for any simplifying once you simplify the square root. Okay. And this is the way Alex wants the answer. I believe Alex doesn't give you a plus or minus button there. So for Alex, you would have to write your answer out like this. On a test, that would be fine for me. Just to give you a heads up. So I like to tell you what Alex does. Okay. So that's how you would write that one out. All right. That concludes